I'm James Brierton in Matthews, North Carolina. This tree, one of many that has fallen here in Matthews and across the two-state region of North Carolina and South Carolina following last Thursday's tornado outbreak. 10 tornadoes in all confirmed by the National Weather Service, who then spent Friday going out and surveying damage like this here at the playground of Matthews Elementary School. The school closed on Friday with power still out and trees like this still down. School was closed in Charlotte, Mecklenburg. Now, the National Weather Service happened to be celebrating its 150th anniversary this week. We're going to be talking about that coming up. The important life-saving mission they played today was all created over a century and a half ago. But first, let's talk more about the recovery efforts here in Matthews and across the region. This tree, the EF1 tornado coming through here on Thursday, caused damage across the region. 95-mile-per-hour winds knocking down trees like this, and also unfortunately taking down some homes where the roofs were damaged when big trees like this fell. All in all, we had about 2 storm deaths across the region, and that's too many. But it could have been a lot worse, and that's why we're going to spend some time in this episode talking about the very important life-saving role the National Weather Service played, because none of those deaths came inside of tornado polygons, and I think that has a lot to do with the role that the National Weather Service plays, getting those warnings out on TV, on radio, to NOAA weather radios, and now to our cell phones, wireless emergency alerts, alerting people like myself that they were in the path of danger. On Thursday, I was trying to make my way to the day job at the TV station when I received one of those wireless emergency alerts on my phone. I happened to be streaming on Periscope at the time. I'm driving here on Interstate 45. As that message comes in, take a look what happens.
Just now receiving an emergency wireless alert on my phone for a new tornado warning issued until 12:45.
Severe thunderstorm capable of producing a tornado was located 9 miles northwest of Indian Land or over Carrollton. Impact. Flying debris will be dangerous to those.
All right, so this actually might be a problem for me. All right, ladies and gents, we might be seeking shelter here in the next little bit because I'm going to be coming right into this, and that is not my intention. As soon as this lets up a little bit, I'm going to go and look for some damage in that area. Right now, I am not moving. I am just to the south of that warning. That is where I want to stay. I do not want to be in the thick of it, but I want to be able to move quickly afterwards to take a look at what might be going on around there.
Because of that alert sent by the National Weather Service and relayed to my phone, I was able to safely pull off the road, get out of the way, let that storm pass, and then I turned north, directly into where the storm had just been, continuing towards Park Road, where the storm had crossed through a neighborhood called Park Crossing. Here's a look at what I saw moments after that tornado came through and as that tornado was continuing east into Matthews. You can see we've got numerous trees down. This one, as it fell, took down a fence. We see several instances of this as we make our way through this Park Crossing neighborhood. Now, all of this damage occurred during the midday hour when a tornado-warned cell came through the neighborhood and it brought down several large pines, just like the one you're seeing right here behind me. To give you a sense of what the aftermath of storm damage smells like, it smells very heavily of pine and also sounds like chainsaws. We have another tree down here. This one just barely missing this brick home as it did kind of fall here and then continue to land, if you take another look, right across their front yard. So a very close call here for the family that lives right at the entrance of Chatham Oaks. This is inside again that Park Crossing Drive neighborhood. Now we are just to the west of Park Road. I was onto the east side of Park Road where the Cameron Woods neighborhood was not too long ago. Whatever came through here then immediately went through there, brought down several trees as well too. Neighbors out there trying to clear the way with chainsaws.
About 10 minutes before the trees started falling, so I was able to be here to help out.
How many trees are down besides what's behind us?
I'm not one for hyperbole, but it's countless at this point. There's trees on houses, there's a lot of roads that are blocked. We're just trying to get cleaned up so people can get through.
And also clear those storm drains, because as you can see, the rain is continuing to fall here at this hour, and so all of this water is going to need a place to run off. So you can see neighbors trying to also clear those drains as well. Back out here in the Park Crossing neighborhood, you can see this fence was no match for whatever came rolling through here a little bit earlier on, knocking down not only the wood sections of the fence, but also tearing it right from the brick pillar. The National Weather Service will be looking at damage like this and like the tree laying across the road to determine what exactly rolled through here during the height of the severe weather. The EF1 tornado that came through Mecklenburg County, not even the strongest of the storms we saw. This EF2 tornado caused damage in Gaston County near Kings Mountain, where it toppled 4 of those huge metal transmission towers that Duke Energy runs to bring power into the region. It took 150 workers this past weekend to get all of that cleaned up and back up and running.
And when they twisted and laid on the ground, I mean, it's just the structures were twisted. If you go look at the footing of that, you'll see where it was a twist. It wasn't a break, it wasn't a bend, it just twisted the structures and they came down together. So it was a very severe wind that caused these structures.
From Gaston County to back here in Mecklenburg County, those were just 2 of the tornado warnings that were issued here for the greater Charlotte area. Numerous storms across the region, a lot of them in that greater Charlotte area. Joining us now from his home in Morganton, North Carolina is Scotty Powell with a look at some of the other storms. Scotty.
One of the first tornado warnings to be issued was for Cleveland and Lincoln County. The National Weather Service was able to confirm an EF1 tornado touchdown 1 mile west of Lawndale in northern Cleveland County. The end location was 3 miles northeast of Fallston, right near the Cleveland and Lincoln County line. One of the stronger tornadoes that we saw occur on Thursday was an EF2 tornado that occurred just outside of the city of Kannapolis, North Carolina, in Cabarrus County. The tornado began just west of Interstate 85 near Lane Street. The awning of a service station was damaged. The strongest damage was found just east along Pless Road, where several homes were damaged from this tornado. This damage suggests wind speeds of 125 miles per hour. The tornado weakened as it moved east, snapping and uprooting trees as it went, and it ended in Rowan County. Again, no fatalities or injuries from this tornado. I'm Carolina Weather Group panelist Scotty Powell.
Thank you so much, Scotty. Continuing our coverage now with even more of those storm survey results from the National Weather Service, here's Evan Fisher.
One of the first tornadoes to occur last Thursday happened in Spartanburg, South Carolina. Now, this one touched down pretty early in the day, before noon. It had a path length of 10.26 miles, so the second longest of the day, and a rating of EF1. This tornado did the most damage near the mall, just to the west, Westgate Mall in Spartanburg. As you can see here, there's a bunch of EF1 damage indicators near the mall area. However, as it tracked closer to Spartanburg, it did weaken a bit, and as it passed through downtown, there was minimal tree damage with just EF0. We had a pair of tornadoes in Stanley County, North Carolina, the first of which was pretty short-lived, only 0.4 miles long, with a maximum width of 100 yards. Peak winds around 100 miles an hour, only did some minimal tree damage. However, the other one was a little bit longer with a path length of 7.3 miles, albeit discontinuous damage. But you can see here that there was damage indicators on the eastern side. Then again over here where there was a little bit more civilization. This tornado occurred just to the west of Albemarle, out in kind of a rural area. But nonetheless, this one did damage a child care center, ripping off some roofing, as well as damaging some manufactured homes with trees that fell onto these homes. This one actually had a maximum width of 1/4 mile, 400 yards, which is one of the more impressive widths of any of the tornadoes on Thursday. Moving a little bit further east, I guess all the way to the east, we actually had one tornado up in northeastern North Carolina in Gates County. As you can see, compared to all the others, if we zoom out, the rest of the tornadoes were down here near Greenville and Charlotte and Greensboro and Raleigh. However, there was one up here in Gates County, rated an EF0. We kind of flip over to the damage survey here. It tracked for about 3 miles with peak winds of 85 miles an hour. Touched down near Taylor Mill Road and Askew Road and crossed Turner before doing some tree damage, as well as a few homes suffered damage, mainly from falling branches.
From Evan Fisher now to Tim Pounds, who joins us with a look outside a storm that crossed from Georgia into South Carolina.
Well, thanks, James. The storm team out of the Columbia, South Carolina office of the National Weather Service confirmed that an EF1 tornado touched down in southwestern Aiken County. This occurred near Vaucluse in the Springfield Church Road area near Stableview Farm. Luckily, there were no injuries or fatalities indicated with this storm. And it was a pretty short-lived storm with maximum wind speeds of 105 mile an hour. The tornado only had a path length of about 1.15 miles and a maximum width of 75 yards. Another area of concern in the Augusta area was the Savannah River. The U.S. Army Corps of Engineers indicated that there was going to be a lot of extra flow from all the rain that occurred in the area, and they had opened the floodgates on the Strom-Thurmond Dam, releasing almost 30,000 cubic feet of water per second. So it was going to be a lot of water going down below the dam in the next few days. But other than that, that's about the extent of the storm report here in Augusta. James?
Also had a lot of water that fell. A lot of water that fell from the sky, making it possible for big trees like this to fall in very spongy soil, but also challenging the water systems, the watersheds, the rivers, the creeks that now have to take all of that water that fell and eventually funnel it out to the Atlantic Ocean. We're watching rising waters along rivers and creeks and waterways that are now having to try to cope with all of that water. When you take a look at the debris that remains days after the tornado outbreak of last week, you have to pause and think for a moment and realize that it could have been a lot worse. But if it wasn't for the folks who tirelessly put in long hours at the National Weather Service, not only forecasting and warning about storms like this, but then spending hours and days afterwards going out into the field and looking at debris and conducting their storm surveys, well, frankly, if we didn't have the National Weather Service, we'd be in a lot of trouble. Now, the National Weather Service celebrated 150 years on Sunday. We, of course, wish them a very happy birthday. Now, we had Tom Niziol on our program a couple weeks back. Now, Tom spent years at the National Weather Service in Buffalo, New York, before coming south to work at the Weather Channel. He now resides just across the border in Tennessee, and he's a bit of a National Weather Service buff, you could say. And he was very happy to spend some time with us to enlighten us on the history and the important role that the National Weather Service has played in its first 150 years and counting. Tom, you got to know the National Weather Service from the inside. What does this 150th anniversary mean?
Well, I'm old. I'm not quite that old, but man, I look back. I have 32 years in the National Weather Service. They're celebrating their 150th anniversary. So do the math, man. I've been there for 1/5 of their entire history. I am old. But I'll tell you, I love going back and look at the history of a National Weather Service for the United States. And a lot of it has its roots back to my hometown, Buffalo, New York, which was one of the original 24 forecast offices in the U.S. when the National Weather Service, under a different name, began back in 1870. It's amazing when you think about the United States and think about the roots of weather and weather observations. My gosh, when our forefathers came here to the U.S., think about the fact that everything they did in their lives had some connection to the weather. I mean, they spent most of their time outside. It was an agrarian society. So two of our most famous weather observers and our most famous original weather people in the United States were two of my favorites, a guy by the name of Ben Franklin and Thomas Jefferson, right? Franklin was amazing. He was one of these Renaissance men that was interested in everything, and he was a great scientist. Franklin, by the way, was the first person to really study and chart something that's right offshore of the Carolinas, known as the Gulf Stream. That really was actually discovered in a way in a scientific basis by Ben Franklin. Franklin also took weather observations every day. How about Tom Jefferson, another Renaissance man? This guy took weather observations on a regular basis, and he shared those observations and developed a network with people that were around him. In fact, the cooperative weather observers in the United States today, their top honor that they can get is the Jeffersonian Award for them taking weather observations. So those are two of the guys that really started things off. You know, we get into the 1800s, and as the country began to expand out to the west, all right, now the beginning of the 1800s, Weather Service actually went into a national operation in 1870. So 70 years before that, the U.S. was moving out and expanding to the west, and based on Thomas Jefferson's suggestions, the Lewis and Clark expeditions, they wanted to take science observations. Most of the Army surgeons who were trained as scientists would take weather observations on a daily basis. And they would mail them back in. They would, arrive months later into places like the Smithsonian, where they would gather this information and bring all this information together, begin to plot it onto maps and try to understand this array of data that we were gathering across the country. But my gosh, none of it was timely. It took months to get that information. So you come across to about the mid 1840s, and we had this amazing invention that takes the science of meteorology and rockets it forward. And it was called the telegraph. Because once you got the telegraph, you could get this data from around the country that these surgeons were taking, and in almost real time, you could get it to one central area where that data could be compiled. You'd have the data quickly, you could analyze it, and then understand what was going on a more real-time basis. And this was all done at a place called the Smithsonian Institution. And Joseph Priestley was the guy that was there, that was gathering all this information and beginning to plot weather maps. Well, we get into the Civil War, and that kind of detoured in some way the expansion of science as far as weather was concerned. But boy, the Civil War brought a lot of technical expertise and other inventions that would then help propel all of this technology and science forward. So let's get into the late 1860s now. And we're a couple of years beyond the Civil War. And the railroad transportation really wasn't coming into its own at that point. So a lot of the transportation that occurred between the inland parts of the country and getting out to the coast in the northern half of the United States occurred on the Great Lakes. There was a tremendous amount of shipping that occurred on the Great Lakes and moving not only goods and materials, but moving people and passengers around. And in 1868 and 1869, in 2 consecutive years, there were over 1,100 shipwrecks on the Great Lakes. Think about that, 1,100 shipwrecks and hundreds of fatalities on the lakes. Well, now I go into 4 cogs in the wheel that I think were most important people that were responsible for the development of a national weather service. Because of all the fatalities that were occurring on the Great Lakes, due to weather, by the way, due to severe weather, there was an amazing guy by the name of Increase Lapham, Lapham. This guy was, again, another Renaissance man. He was a geologist, and he was, at that point in Wisconsin, very interested in the weather. Again, a scientist by many, many means. He plotted weather maps, and he sent a lot of news clippings to his congressional representative about all these fatalities that were occurring on the Great Lakes. And there has to be something done to develop some type of weather warning system for these bad storms that were coming across the Great Lakes. So in 1869, I believe it was, Increase Lapham sent this letter out to his congressional representative, another second cog in the wheel by the name of Halbert Payne. And Payne took this information and introduced a resolution under Ulysses S. Grant to the United States Congress. And on February 9th of 1870, the resolution was passed to then bring into service a national weather service for the United States. And it was under the direction of the U.S. Army Signal Corps at that point. Why the Signal Corps? Well, it now brings in our third character. Our third guy that was in big responsibility and a big part of developing a national weather service was a guy who was in charge at one point for the Signal Corps in the U.S. His name was General Albert Meyer. And Meyer has a connection to my hometown of Buffalo, New York. But Meyer actually developed a signaling system during the Civil War of using flags to send signals between military installations. And this signaling system, or wigwag system, was in play, and it was in place during all of the Civil War. Meyer was an amazing character because he had a great military background. He had the ability to organize, and he also was in charge of this signaling system that they were using at that time. And so when Ulysses S. Grant signed the orders to bring into law a national weather service across the United States, Albert Meyer was brought in as the first head of the National Weather Service. And Meyer then brings in the fourth cog in the wheel, the guy that really made this happen from a scientific point of view. His name was Cleveland Abbey, and this guy was a scientist by every stretch of the word. He is the person who first began to issue forecasts, actual weather forecasts across the eastern part of the United States, and he had a tremendous science background. And when he came into that first beginnings of the National Weather Service, it was Cleveland Abbey who introduced science, who introduced coursework, who introduced the theory of meteorology and the science of meteorology to those employees who were hired to man the 24 original offices across the United States. It was really a fascinating time. And from there, the ability to bring in weather data and weather observations led very quickly to production of weather forecasts. Within a couple of years of the formation of the Weather Service, these daily forecasts were something that everybody asked for. People understanding that they might not be all that accurate all of the time, they weren't able to do the kind of detailed forecasting that we can do these days, but they had an understanding of the basic concept, in most cases, of weather moving from the west to the east across the United States. With the ability to plot these maps, the early forecasters were able to trace storms. And as storms were moving from Chicago to Detroit to Cleveland to Buffalo and out to New York City, these forecasters could time to some degree the occurrence of this bad weather that was coming in that direction. And as they would do that, they would put these signal flags outside of places like post offices and other places where the public would frequent within these towns and cities. And so a quick walk down the street, someone would look at the flag and they would understand that the red flag with the black on it, okay, again, if you were in a coastal area, could mean a hurricane warning that was out. There were other types of flags that they used to get this information out. But it was amazing how quickly the science grew and how quickly the Weather Service expanded as we went through that time frame right after the Civil War.
Tom, if you think back to what they started with and what we have today, if you could imagine, what do you think they would make of all the tools we have today?
Well, it'd be like being on a different planet. I mean, you think about the fact that, yeah, they were getting weather observations, but there was no such thing as a satellite to monitor the weather from space, a radar to look at precipitation, even heaven forbid, a computer model, something that would actually foretell by using basic laws of mathematics what the weather would be like several days or maybe even into weeks in advance. It would be like a different world. And by the way, because I'm such a senior person at this point with a history of being in the National Weather Service, I came into the Weather Service at a time before computers were even introduced into weather forecast offices, at a time where there was something called a teletype machine, a machine where it actually typed out the weather observations onto this giant typewriter. And as weather forecasters, we would rip that information off of this machine and sit down and hand plot and draw weather maps. I got to do that when I was an intern in my first couple of years within the National Weather Service. And to go from that to what we have today is amazing. So I can't imagine what someone like Cleveland Abbey would be thinking if we were able to place him into a science office like we have within the National Weather Service today.
This is a very specific reference, and I'm not sure how many of our listeners will know it, but if you've ever been in the New York metropolitan area, and Tom, you're obviously from the state, and you listen to 1010 Winds AM, they have that tick, 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 tick. That's what I'm imagining when you say teletype, just all of that constant automatic typing.
So the RFK bridge getting up to the Bronx is also very slow, and because of that, leaving Manhattan.
That brings back memories for me, because that was the background noise in the Weather Service. It was like the old newsroom where you heard that, and that was the teletypes rattling away. I'm going back to my history. Only 35, 40 years ago in the National Weather Service, when I first came online, that's when we were first beginning to get satellite pictures, we'll call them, into the National Weather Service office. Now, we get satellite data today at minute intervals. It comes in on the computer. We run these huge loops at any resolution in any part of the globe on a regular basis. Everybody can do that online these days. In the weather office back then, we would get one image that would come in every hour. And if you wanted to do an animation of what was going on, all those images were placed on a clipboard. And you literally would take your fingers and take the pictures and let them go, and you could see the clouds moving across the eastern part of the United States. That was our animation back then. And that was after a tremendous increase in science and technology. It's fascinating because, as we all know, wars are terrible. War is hell. But wars also bring out tremendous advances in technology. And, World War II pilots, they were responsible for discovering the jet stream. As we got into World War II and immediately after, we developed the first large-scale upper air network across the United States with the launching of radiosonde balloons twice a day to get that information from the upper atmosphere, because weather occurs on 3 dimensions, right, throughout that depth of the atmosphere. The advance of weather radar. My gosh, you took military radar, again, developed in World War II. And then after that war, they not only saw airplanes when they were looking at the radar, but they saw these features that kept getting in the way of them looking at airplanes. It was precipitation from storms. And, we turned that into the ability to monitor weather systems and then get into the tremendous science of severe weather and understanding tornado genesis and tropical storm formation from all of that technology. So it's just been amazing to watch the history. And it all began back there in 1870 when there was concern for the loss of life on the Great Lakes and of course, along the coastal areas from shipping as well.
Tom, you're talking about the advances in technology. One thing that kind of comes to mind is the advances in the warning process.
Trying to explain to the younger generations that we didn't have things like cell phones, right? Just a generation or two ago, with these text messages and alerts that came across at any time of the day or night, the ability to communicate that information has saved countless lives and will continue to do so. And the ability now to be able to put out 911 messages to a huge area, an entire community, to get that information out, has been married with the technology that allows us to be more confident to get those warnings out by being able to use something like a Doppler radar to understand what we should be warning on and what we should not be warning on. Because in the early years of issuing severe weather warnings in particular, but certainly all types of warnings, much of the public was very frustrated with the fact that the weather forecaster may, for lack of a better term, cry wolf a lot of times and send these warnings and watches out and not be able to verify them because we just didn't have the technology to do that. But we've got that technology now. And to be able to then marry that to the ability for people to get warnings anywhere at any time, day or night, it has just gone a tremendous way to save lives across this nation.
Talking about communication, and then I'll toss it off to someone else. One of the biggest tools that I think we all in this chat utilize is NWS chat, and the ability for the forecasters and the weather office to communicate with TV, radio, storm spotters out in the field. I mean, just the instant communication that we have, I think, is pretty cool, and it's cool to see the advances in the National Weather Service with that.
That's a really important point. And what it's done also is it's changed the responsibilities and the type of work that goes on within the National Weather Service offices. a decade, now I should say more than that, a generation ago, the main job of the National Weather Service forecaster, the meteorologist, was to issue the forecast. And now we have many, many tools that allow that process to be very, very fast, very efficient, and very smooth. But what the forecasters do now, where they really, really make a difference, is what we refer to as decision support or decision support services. That ability to get that information and get it out and let our special customers know exactly what is happening, when it is happening, contacting emergency managers and working with the emergency management community to have their resources ready to go, to be ready to respond when the weather is coming through. And also, you mentioned this tool that is used on computers called NWS Chat. It's the ability for the forecast office to chat or to talk or message to many of its users, its media, its emergency management system, those types of individuals, to get the most reliable and timely information back and forth from those communities and sending out their thoughts from the National Weather Service offices. I found it fascinating when I worked at the Weather Channel that we, within a matter, and I mean this, within a matter of less than a minute in many instances, a damage report, say somebody had a half-inch hail that came down in their neighborhood outside of Charleston, South Carolina. And they sent a report in on their phone to the National Weather Service saying, we got hail here. Within a matter of a minute or so, the Weather Service gets the report, pops it into a computer that goes into this system. And at the Weather Channel, our graphics meteorologists were watching that data coming in. And when they picked that data up with the click of two buttons, it ended up on air. I was amazed to see how quickly that process took. And it's the ability to get that information and communicate it out to the public, because time is of the essence, especially with severe weather. So it's another huge increase in technology that, once again, is helping to save lives.
Tom, I don't know if there's any telling what this world would be like without the National Weather Service. So let me try to phrase this closing question to you this way. What would day-to-day life here in the United States be if tomorrow morning we woke up and there was no National Weather Service?
I think it would be chaos. If you think about how much of our economy and daily life is tied directly to the weather, and the way you see that most succinctly is being in the checkout line at the grocery store, because everybody's talking about it. You have to know what's going on with the weather if you're going to react with the real world. Everything from our transportation to our agriculture to daily life in general revolves around the ability to understand how nature, how the atmosphere is going to impact us over the next several days. Without the National Weather Service, I think we would be way, way behind in where we are right now.
We again thank Tom for his time, and to all of the folks at the National Weather Service who continue to keep us safe each and every day. We can't thank you enough. And to you at home, thanks for joining us for this special edition of the Carolina Weather Group. For all of us, I'm James Brierton in Matthews, North Carolina. We'll see you again real soon.